Hi everybody, my name is Joey and I'm the Perfect Score Tutor. I've gotten perfect scores on both the SAT and ACT. However, I'm here today with a copy of the 2024 free response questions to the Calculus AB exam. I'll be breaking down the free response questions into detail so you can predict how you did on this exam. Or if you're looking at this from a future test date, you can use this walkthrough to study for your upcoming calc exam. So question 3 is a differential equation question. They give you a gnarly looking differential equation here, and it tells us that h is measured in feet and t is measured in hours, and they give us a starting point. Part A fortunately isn't going to be super complicated. They just give you the slope field and they want you to sketch the solution curve. So all you got to do is plot your point there, which they already did for you, and then just kind of follow where the curves are going. I think of this as like maybe a jet stream or a river current. So as long as you kind of roughly approximate this graph and show that there's a lump here, a max around like 3.5-ish, I think you get full credit for this question. So for part B, it says for t is between 0 and 5, it can be shown that h is greater than 1, and it wants you to find the values of t for which h has a critical point, and then to determine whether this critical point corresponds to a max, a min, or neither. And then as usual, it asks to justify your answer. So the definition of a critical point is where your first derivative is either equal to 0 or undefined. Here there's no like square root, or there's no variable in a denominator, so there's not an undefined point. However, we can set those factors equal to 0, right? So we would get a 0 where h is equal to 1, right? Plugging in 1 would give us 0. And the other time we get a 0 is when cosine of t over 2 is equal to 0. Notice here in the question it says h is greater than 1 for all these values, so then this would be an extraneous root. So basically all we need to do is solve where cosine is equal to 0. Well, cosine is equal to 0 at pi over 2 and at 3 pi over 2. So then t over 2 is equal to pi over 2, and then t over 2 is equal to 3 pi over 2. And then when we multiply both sides by 2, we would get t is equal to pi, and then we get t is equal to 3 pi. Now thinking about our range of values, it says t is between 0 and 5. So 3 pi is a little bit too big, right? That's between 9 and 10. So this is another extraneous root. So the only critical value we have is where t is equal to pi. Now with differential equations, the best way to find if it's a relative min, max, or neither is to use the second derivative test. Okay, so I'm probably going to need all this space to calculate the second derivative, but it's going to be d squared h over dt squared. I'm going to need to use the product rule. I'm taking the derivative of both sides with respect to t, by the way. So it's going to be 1/2, and it's going to be first times the derivative of the second. Derivative of cosine is negative sine of t over 2. Chain rule, so times 1/2, plus the derivative of the first. Now the derivative of the first is 1 times dh dt times the second. So this is the whole second derivative with respect to t. So anytime I took the derivative of an h term, I had to plug in a dh dt. Now what was the point that we calculated earlier? We calculated the point was t is equal to pi. And so let's figure out what's going on here when I plug in t is equal to pi. Well, this h minus 1 stays here. This negative sine of pi over 2, negative sine of pi over 2, sine of pi over 2 is 1, so then this is going to be negative 1 times 1/2. Plus, well, what is this dh dt? It's a critical point, right? So dh dt is equal to 0 at that point, so this whole thing just goes away. And then what else? The question tells us that h is greater than 1. So if we want to simplify this, this is going to be negative 1 times 1/2 times another 1/2, so it's negative 1/4 times h minus 1. So this is the value of my second derivative. Now the question says that h is always greater than 1. So then if h is always greater than 1, my second derivative is always negative. So then I can use that information to justify my answer. derivative. Because the second derivative of h is negative for all t is between 0 and 5, and because h prime of pi is equal to 0, t equals pi would be a relative maximum according to the second derivative test. So remember, for the second derivative test, that occurs when your first derivative is equal to 0. Then you look at the concavity of your graph. If you have a concave down graph, then you would have a local max. If you had a concave up graph, you'd have a local min, and then if you didn't know your concavity, then you couldn't use the second derivative test. Then, as usual, in a differential equations question, they want you to find the particular solution. So h is everything that's going to go on the left side. Anything with the t is going to stay on the right side. So I'm going to divide over the h minus 1. And then I'm going to multiply the dt over to the right-hand side. So it's 1/2 cosine of t over 2 dt. And now I'm going to integrate both sides. So the integral of 1 over h minus 1 is ln of absolute value of h minus 1. And then the integral of 1/2 cosine of t over 2, well, the integral of cosine is sine. And then you can either use u substitution or just know that the chain rule for integrals is you're going to divide by the integral of what's on the inside. And you're going to plus a c because you need your coefficient of anti-differentiation. These 1/2s cancel out. So then ln of absolute value of h minus 1 is equal to sine of t over 2 plus c. Now let's see if now is a viable point for us to plug in. I don't like the ln because usually it would cancel out, right? But it doesn't cancel out over here. So the next step is to take the e of both sides. So the e and the ln cancel out. So you get absolute value of h minus 1 is equal to e to the sine of t over 2 plus c. Now remember that when you have two things being added in the exponent, you can rewrite it as e to the sine of t over 2 times e to the c. So this is just the exponent rule, and then e to this unknown constant is just going to be a big constant, so it's going to be h minus 1 is equal to c times e to the sine of t over 2. Now is it an appropriate place? Let's try plugging it in then. So if we plug in 4, well, we know our thing's going to be positive, so we can remove our absolute value, so it's just going to be 3 is equal to c times e to the sine of 0. Well, sine of 0 is just the y value over here, so it'd just be e to the 0 power because sine of 0 is 0. So then we know our coefficient is going to be a 3. So then our equation is going to be h minus 1 is equal to 3 times e to the sine of t over 2. And then we just plug in, we just plus the 1 over. So h is equal to 3 e to the sine of t over 2 plus a big 1. And then you also want to just plug in the point again just to make sure that we get a positive number, and we do. So we did the right thing by just removing the absolute value sign. So predicting points, this one's a really difficult question. I don't know how they're going to get 9 points out of it, but I'm pretty sure that the graphing of the slope field is just going to be worth 1 point over here. For the second part, you're probably going to get 1 point for calculating your critical value. You're going to get some sort of probably 2 points maybe for even calculating your second derivative. And then you're going to get 1 point here for your explanation, which utilizes your second derivative test. Usually within these 2 points, they'll probably give you a point for at least attempting the product rule, and then the other point for correctly doing your derivative. So this is 3 points over here. And then usually for the separation of variables, that's either worth 4 or 5 points. You'd get 1 point for correctly calculating this antiderivative, 1 point for correctly calculating that antiderivative, 1 point for plugging in your initial value to get your C, and then 1 point for getting your final answer. Sometimes they might squeeze an extra point out of here. And if you do not include a C value, it's very likely that the max credit you can probably earn is 2 out of 4 or even 1 out of 4, depending on how salty the AP readers are feeling this year. Thanks so much for watching this video. If something was unclear or you needed me to break down an explanation even more, feel free to leave a question or comment below.